6.9 Proofs using coordinate geometry. So as we ended our previous lesson, we were looking at the proof of a trapezoid mid-segment theorem. We set up our proof and we did the following steps. We looked at finding the midpoints, and then we looked to prove that the length of the mid-segment was parallel to both bases, and it was also half as long as the sum of the bases. So in this lesson, we're actually going to do the proofs. So we're going to prove geometric relationships using variable coordinates, which we also discovered in lesson 8. So let's look at example 1, writing a coordinate proof. So use coordinate geometry to prove the midpoint of the hypotenuse of a right triangle is equidistant from the 3 vertices. So what we're trying to do is we're trying to prove that this midpoint M is the same length from E that it is to O that it is from F. So that is what we're trying to prove. Now they've given us our given and what we're trying to prove. We're trying to prove that these 3 are the same. They give us that triangle OEF is a right triangle, which means that this is a right angle. It says that M is the midpoint of EF. So those things are given to us. So let's go back now and let's try to prove that these are going to be congruent. Now, like before in our previous proof, we first have to locate the coordinates of M. So we're going to use the midpoint formula. So we're going to take the midpoint formula. We're going to take our x's. We're going to have 2a plus 0 divided by 2. And then we're going to add our y values, which will be 0 plus 2b divided by 2. Simplified down, this gives us 2a over 2 and 2b over 2, which then the 2's cancel and we're left with just a and b. So the coordinates of M are going to be a and b. Now, the next thing we want to do is we want to prove that these segments are congruent. So by the midpoint formula, we were able to show that this was the midpoint. And by the distance formula, we're going to show that these are going to be congruent. So let's start with the distance formula. Let's look at our length from O to M. So the coordinates of O, once again, are the origin, which are 0, 0. So when we're doing the distance, it's almost easier to just do the furthest one minus the one furthest to the right minus the one to the left. So we'll do A minus 0 all squared plus b minus 0 all squared. Now this gives us the square root of a squared plus b squared. Now we cannot separate these two because they are separated by addition here. They're not one term all squared. It's 2 different terms squared. So our answer for the length of OM is a squared plus b squared. So now let's look at the length of E to M. And so from E to M, we will have a minus 0 plus all squared plus b minus 2b all squared. So this one we have to do a little bit of work because we're going to get a squared, and over here we get b minus 2b, which is going to be a negative b squared. And when you square that value, we get a squared plus b squared, because a negative b times a negative b is a positive b squared. So that's our second one. So now so far we've seen that both of these are the same. So now let's look at our final one. Final one is going to be the length from F to M. So once again, we use the distance formula. We're going to do 2a minus a all squared. We're going to do 0 minus b all squared. So this gives me a squared. This gives me a negative b squared, which then becomes a squared plus b squared. So that means that all 3 of these are the same length. So what we've shown, since OM is equal to EM, which is equal to FM, the midpoint of the hypotenuse. So basically we're going to restate what they're giving us, what we're looking for. So the midpoint, the hypotenuse, remember the hypotenuse is the longest side of a right triangle, is equidistant from the vertices of the right triangle. All right, so let's go to the next one. So what advantages of using coordinates with a 0, 0, 2b, 2a, and 0, 0, rather than just using 0, 0, 0b, and a 0? So the advantage is when we're using a midpoint formula, when we're dividing by 2, the 2 cancels out and we're left with just the variable instead of ending it with a fraction. So by using any factor of 2, it avoids fractions. And we know how much you like fractions. So let's move on to example 2.